Hello there. I'm Sham from DSA A2 batch 20 BLC 1027, and this is my digital assignment too. This is a program called FoodApp that processes requests from different restaurant chains, similar to apps such as Zomato, Swiggy, etc., Foodpanda, etc. Here I've combined a linear and a non-linear data structure to maximize the efficiency. I chose queue and heaps respectively because we'll see the reason later. Now let's look at the working of this program. First, I've defined a class called FoodApp. The primary member here is chain, as you can see here, which is essentially a queue of heaps that stores a pair of int and string. With this pair tuple, this one, with this pair tuple, I can combine the time left till delivery and the name of the restaurant in which the order has been placed. Since the orders are being placed from multiple restaurants one after the other, the most obvious data structure to use would be heaps. Using the priority queue structure, the data can be sorted into a min heap, where the topmost value will be the request that is due in the least amount of time. Then a queue of the aforementioned heaps can be made to speed up this process and make it more streamlined. In the real world, ordering food through apps like this depends on various factors other than just time, like the distance and the conditions of path taken to arrive at the distance. The shortest path won't always be the fastest path. Thus, a parent queue structure is always essential. Coming back to our program, here I've made a default constructor to push a priority queue called last rec. This basically just prevents the heap from being empty while executing the program. And then I have three member functions called insert, delete, and find. Delete is basically delete, but since delete is a reserved keyword, I've used the word delete. Anyway, uh, insert and delete are pretty simple functions. They just push a new priority queue inside the original queue and then pop the heap from outside it. Now, the one thing you'll note here is you can only push from the back and you can only pop from the front. So I've used those functions to make this happen. And I've used the make pair function to convert the int and string into a pair in order to insert it inside the heap. The tricky function here is find. Here, here we define a cursor called cur, which is right here. This cur points to the heap that's in the front of the queue. That is, it refers to the heap that was made first, the oldest placed order. Then we can check the equality of the topmost element, which is basically the minimum element. I've used minus time here because it ensures that the least time is always at the top of the min heap. And then I compare the string that we can get from the user. If it returns true, then I will return true in this bool function, or else I'll return false. Then let's go to the main function. Uh, Here I get the number of requests from the user, and then I get the values from the user, and then I insert it into the priority queue. I've also implemented a very important functionality that will be very essential in food processing apps like this. That is the delete order function. I've implemented it inside the main function itself. So what I do is I ask the user the number of requests that he wants to delete from the chain. Let's say the user actually entered 5 restaurant orders into our heap, and then now he wants to delete 3 of them. So he types in the value 3. So I get he types in the value 3 and I store it in the variable m. So I do a loop called while m minus minus, which basically means that the loop runs thrice. And then while the loop runs 3 times, I call the delete function, which removes 3 values from the top of the heap. So basically, it removes the 3 least values from the heap. That means the 3 most recent orders will be removed from the structure. That's the delete function. And next I also have a search function, which just uses the find one that is in the class. We get the time and the restaurant values from the user here, store it in t and re, and then invoke the find function. If it returns true, then we'll display found in our chain. If it returns false, then we'll display not found in our chain. And then while ending the app, we will display have a good day. So this is a simple processing program that implements queue of heaps in order to be max efficient. Now let's run the program and see how it works. Um, let's try 4. This is the first restaurant time. Let's put 10. Name, let's put A to B. Uh, I'll keep entering the values. Now it's asking if we want to delete any number of requests. Let's say yes, and then 2. It has successfully deleted the 2 least time orders, which will be pizza. It will be Papa John's and A to B. Now let's try to search. Yes. Um, and yeah, it's found in our chain. Have a good day. So yeah, that's how this program works. It uses queue of heap structure to process requests through a chain. That's about it. See ya.